All right, you guys, this is Professor Vet, and I'll walk you through your mock final exam for Philosophy 12, Introduction to Logic. The final exam will consist of two parts. You'll be tested on natural deduction proofs and informal fallacies. So this review session is divided up accordingly into the natural deduction proofs and the informal fallacies. On the final exam, you will be given each and all of these rules. The one that I handed out in class mysteriously was missing constructive dilemma right down here and conjunction right over here. So I added them in, and that should be enough. Remember, yeah, okay. All right, let's get going. Let's see how that looks. All right, you guys, so we're going to go ahead and start here on proof number D. I've increased the font size so you can see it a little bit better. Remember, when we start a proof, we want to look for low-hanging fruit, right? In other words, we want to look for straightforward applications of rules. And when you look at this proof, there really isn't one, right? We have a not Q implies something, a not T implies something else, and then we have not both Q and T. The only thing that you can do, there are lots of things you could do, but really the number one thing that I would urge you to do at this point with line 3 is to do a De Morgan's on line 3. I will tell you why I'm going to do that in a moment, but essentially I'm going to do this because I'm going to need it later with an application of constructive dilemma. So I took not both Q and T, and I did a De Morgan's on it to say not Q wedge not T. So if you look up here at De Morgan's, I did this line right here. I had not, I did this line right here. That's what I get for not looking. I went from not both P and Q to not P wedge not Q. And so that says not both peanut butter and jelly, therefore not either peanut butter or not jelly. Okay, so when I do this because when I look at line 1 and 2, I see the very beginnings of a constructive dilemma. So I'm going to combine lines 1 and 2. Sorry, I cheated. And I will expand this a little bit so you can see it. Okay, here's all I've done. And I'll switch this to a dot. But this is the last problem I'm going to do that on because I would much rather use the ampersand. The dot is excruciatingly time consuming to do on Word. Okay, so here we go. All I've done is I've converted line 3 into a De Morgan's because I know I'm going to use constructive dilemma. Constructive dilemma is this rule right here, and it goes like this. If it's a cat, then it has worms, and if it's a dog, then it has fleas. It's a cat or a dog, so it has worms or fleas. Well, I noticed that immediately with lines 1 and 2. I have a not Q and a not T, and I also have a Q and a T locked up in 3. So I was immediately thinking, oh, this is going to be a constructive dilemma. So that's all I did. I did a De Morgan's to get not Q, wedge, not T from line 3. Then I combined lines 1 and 2 because I knew that this is going to put it in the form of a constructive dilemma, which is going to then allow me to conclude C and B, right? So I'm right here, right? P implies Q and R implies S. So I'm going to derive P, or I have P or R, so I'm going to bring down Q or S. So this right here is my Q. And then I'm going to do, Q, wedge, and then the other part, which is B and H. B and H. Okay, so do you see that? This is P implies Q, so there's my Q, and this is R implies S, so this is my S, so this is my Q wedge S, and that comes from 4-5 disjunctive syllogism. All right, so we're rolling here. And you know what I'm going to do on the next proof? I'm going to clean up the sites a little bit, just so that they look a little bit cleaner and a little bit less confused. Okay, so now I have this sentence, C and B wedge B and H. Anytime I see something that looks like this, that has two parentheses and maybe a wedge or an and, that has one letter, I think distribution. So here's distribution. And the way to think about distribution is, I have two B's here. Well, I can take one of them out. So in order to line up a nice distribution, I'm going to move around the letters a little bit so that they're in the proper order. So I'm going to take line 6 right here, and I am going to switch the order of C and B here just so that I can then do a distribution on that. So this is going to go 6, and it's calm. Okay, so that's calm right here. Calm just says if you have cake or ice cream, then you have ice cream or cake, right? The order of the elements in a disjunct or a conjunct don't matter because they don't affect the veracity or the truth of the statement. So B and C is the same as C and B for logic. Remember, the truth table will be exactly the same. So now that I've done that on line 7, my next line 8, I'm going to do a distribution. I'm going to essentially take away the B. And a great way to remember distribution is that you take the operator that's on the outside and put it on the inside, and the operator that's on the inside and put it on the outside. So the ampersand is on the inside. I'm going to put that one on the outside, and then the wedge was on the outside, so I'm going to put it in the, oops, what's going on? What's going on? Stop. I don't want this. Stop this, whatever this is. I'm telling you, man, sometimes can't catch a break. Can't catch a break. Okay, so then I'm going to do the wedge. Okay, so before I was so rudely interrupted by some pointless feature of the Mac, hold on, let me do my little rule justification, and then I'll tell you what I did here again. All right, 7 distribution, right? Dist. Okay. B and C wedge H was taken from line 7, which said B and C or B and H, right? So this right here, line 7, turns into line 8 by an application of this rule right here, distribution. So I have B and C wedge H. It's looking good. My conclusion is going to be a B. Now, notice that we're pretty far into this proof, and this is the first time Professor Vitt has mentioned the goal of the proof. Remember, when you're working a proof, you've got to feel comfortable just doing a rule, right? As long as the rule application is proper, there will never be a problem. It will always be okay to do that. So here we go. B and C wedge H is just an application of distribution. So now I'm going to go ahead and conclude B, and I'm going to do that by, think in your head, 8, whoops, there we go, 8 simp, okay? So here we go. I get B from line 8, B and C wedge H. In order to get there, I had to do a De Morgan's and a constructive dilemma. If this proof was difficult to see the first time, that would make sense to me because it involves a De Morgan's and a constructive dilemma. If you are ever in a position where you are not sure what to do, just start looking at distribution and think, is there something that I'm going to do to take away, right? Or start looking at constructive dilemma. Is there something here that they've given me to build a constructive dilemma? The reason why I say to think of those two rules is because they are so complex when you're first starting that you tend to forget them or forget how they would apply. And so if you really are slammed and you're up against the wall, just start looking at distribution and constructive dilemma and say, maybe the answer is right there. Okay? All right, let's move on to our next one. Hey, you guys, this is Professor Vitt, and we are now on numero Q. The letters aren't in any particular order. It was just the order that I cut and pasted them in. So we want to conclude for this one, not I wedge P. I'm looking at for an I wedge P in my premises just to get a feel for the proof, and I see it right here. So however I get it, who knows, but it's right there. So I'm going to peek for a second, and I'm going to say, is there some way I could get this out of all of this? Yeah. If I got rid of the H, right, by modus ponens, then I would have this. And then if I had a not E, then I could, by modus tollens, get that little disjunct that's the antecedent of the second half of the antecedent of the consequent for the full line. So the other way to put it is, if I get a not E, then I can get the first part of this conditional right here, which is itself part of a bigger conditional in line 1. So I get some roadmap for how the proof's going to go. If you don't see that far into it, don't worry. There's no need to. You're going to be able to just work the proof, right? And look for low-hanging fruit, and you will get there, I assure you. So let's do line 4. Okay, I have an H. I have a line 2 here with H wedge W implies not E. So I'm going to do addition. H wedge. Ooh, look at that caps lock, or that bold. Let's turn off that bold. That's a little too intense, isn't it? We don't want to. We don't want to tear the place down, right? We just want to finish the proof. Okay, H wedge 8, that's easy for me to say. H wedge W is acquired by an application of addition to line 3. So let me go 3 addition. All right, now, my next line is going to be line 5, and I'm going to take, come on, there we go. I'm going to take line 4, come on. I'm going to take line 4 and do a modus ponens on line 2 with it. So I'm bringing down my not E right here. So I'm going to just cheat and do this. Bam! Okay. So now I get line 5 by an application of modus ponens to lines 2 and 4 modus ponens. There we go. All right. Now, right, I love this. The tabs work differently depending on... It's okay. All right. Now I have a not E. And I'm kind of stuck, right? It looks like, I don't know what I'm going to do. Well, you can do modus ponens on lines 1 and 3, and you might have already done that. That might have been the first thing that you did. It might have been more obvious to you to do it that way. If so, that's fine. It doesn't matter what order the proof gets worked in, provided you work it. As long as each rule application is okay, I don't care about the order. It's just not relevant. Unless the order is required for the rule, right? But that's just not going to be an issue for us at this point. Okay, so we got all this junk, and I got it because on line 5 I have a not E, right? I got it from modus ponens right here, but I still had an H in line 3 and applied in a straightforward way to line 1, so I brought down I wedge P implies E. Now, I'm going to clean that up just a tick, remove the brackets. Remember, we're not too worried about brackets right now. But if you look at line 5 and 6, you'll see a straightforward application of modus tollens, right? If I'm in San Francisco, then I'm in California. I'm not in California, so I'm not in San Francisco. Wedge. Maybe, can I get it smaller? Wedge P. There we go. And that's going to be 5, 6, modus tollens. Okay, so hopefully this makes sense. It is our conclusion. This was a 4-step proof, right? The toughest part was seeing the addition that you needed to do on line 1, but you could have just started with modus ponens and gotten this, and then worked in the alternate way, right? And then done the other steps next. Doesn't matter. This rule... this proof is not too difficult, right? It's not impossible, but it's not, once you see the addition, it's just a question of modus ponens and modus tollens. Okay, I hope that was helpful. Let's do another one. Okay, problem number I. Okay, so for I think the first thing you want to do is try and figure out if there's any low-hanging fruit. We only have 2 premises. And the low-hanging fruit that we have is something called modus tollens. And modus tollens works like this. If I'm in San Francisco, then I'm in California. I'm not in California, so I'm not in, that's right, San Francisco. Okay, so I'm going to do a not, and then I'm going to paste that. That's going to be 1, 2, modus tollens. And even though we're almost done with this proof, I'm going to push that out just so it looks a little bit nicer. Okay, now let's go to number 4 here. Okay, so now I have not O wedge M. My conclusion, first time I've ever been concerned with it, is a not M. So it looks like, oh no, am I going to do a DS? What am I going to do? You're going to do a De Morgan's, if you can believe it, on line 3. Remember, De Morgan's lets you go from not this or this to not this and not this. So I'm going to derive not O and not M. I'm going to get it from 3 De Morgan's. Okay, so that, we're loving it. We're absolutely loving it. Okay, and now, right, so De Morgan's lets you, remember how De Morgan's works. It's going to take the negation, it's going to attach it to each one of the letters, and then it's going to flip the wedge into an and or an and into a wedge. So remember, you're taking your drink of Captain Morgan's spiced rum, you spit it out, and you get that juice on the O, right? The negation goes onto the O and the M. They get sprayed with your disgusting Captain Morgan's, and then, oh, your tummy turns because it tastes gross, and you go from a wedge to an and. And then the conclusion is available by simplification, not M, and that's going to be 4 simp. And remember, simp just lets you say, if you've got peanut butter and popcorn, then you've got peanut butter and you've got popcorn. So if I have a conjunct on one line, I can take the 2 members of the conjunct, the 2 parts of it, and break them down to another line. And that's it. This is a super straightforward proof. The only trick to it is probably the De Morgan's or just seeing the modus tollens to start. I can imagine a world where I stare at this proof for a little bit, right? Because I just don't yet see the modus tollens. And if that happens, that's fine. The next time you work it, you'll remember it. Okay, let's crank out another one. We're just zipping right along, right? Professor, it is hot in my garage right now. I'm not even going to lie. I'm going to have to turn on the fan and another light. Okay, so let's look at problem T. We want to derive not A. We have a not C. So let's just see if there's any low-hanging fruit, right, that we can work with right now. Ah, okay. Hold on. Get this lined up. I know this is silly, but honestly, if it's not done, I'm sure it looks like it just drives you nuts when you're looking at it on the screen like, line up your assumptions. Okay. I have a not C implies A implies C. I have a not C right here, so I'm going to bring down A implies C to line 3. That's going to just be 1, 2 modus ponens, our old friend modus ponens. Remember, all modus ponens does is it says, if it's green, then it's colored. It's green, so it's colored, right? Meaning it has the property of having a color. It's not invisible like Wonder Woman's jet. Okay, you can also do the geography example. If you're in San Francisco, then you're in California. You're in San Francisco, so you're in California. Okay, now we want to conclude not A. I have an A right here. The solution will be one step. It's going to be an application of modus ponens' friend, his cousin, modus tollens. And the way I'm going to derive not A, I will tell you, is going to involve lines 2 and 3, and modus ponens' cousin, modus tollens. So we have a not C. A implies C, right? If I'm in San Francisco, then I'm in California. I'm not in California, so I'm not in San Francisco. The end, right? This may be the easiest proof on the exam. 2 lines. Make it happen, right? Just a modus ponens and a modus tollens. All right, let's do another one because we're zooming right through all these. I'm going to turn on a light and a fan. So give me a tick. All right, so we just finished T. We're going to work on L. Let's do L. All right, so how is L going to work? Okay, let's get our numbers lined up here. Sorry for this little delay. All right, let's see if the tab works. Nay, it doesn't. And it even puts it in a totally different font. Look at that. Hey, cool it. There. That's as good as it's going to get. Nice. Thanks. Thanks. No idea. We're just going to go with it, folks. I'm just going to go with it. Oh, I know what it's doing. Hold on. Let's just switch it all to Times New Roman. Sorry about all this. Sorry. You can fast forward the 1 second that it takes me to do this. 2, 3, 4, 5, 6. This is because I've loaded up so many fonts on this machine that it just can't handle it anymore. Times New Roman. All right, here we go. For everyone. Okay, Times New Roman for everyone. Okay. We want to derive F, right? We have a bunch of, we have a conjunct here with a bunch of stuff in it. How are we going to do it? Well, I think the first thing I would encourage you to do is just break apart the happy couple. So if you look at line 1, you have H and C and T. And so H is a happy couple with C and T, so we're going to break them apart, right? This is a polyamorous group. 1, simp. Remember, simp is just a way of saying, hey, if I have a conjunct, I'm going to take one member of that conjunct and put it on its own on a subsequent line. All right. And of course, the numbers ain't going to, it's not going to tab. Give it up, Professor Beta. It's not going to tab. Okay, and then I'm going to do the same thing for C and T. Right? That's also 1 simp. All right. Okay, so we're there, right? Okay, now we're on line 5. Okay. I still have C and T. Remember, the ampersand is just the same as the dot. It's just much more difficult to get my keyboard to do that. And yes, I know I've tried with macros. It's a nightmare. Okay, so I have C and T right here. And I want to get an F. I'm going to break this couple apart again. And I'm just going to bring down the T. So I'm going to do line 4, simp. And my thinking here is that, I mean, as I'm scratching my ear, right, as I'm pulling a raccoon out of my ear, I don't know how I'm going to use T, but I don't see any way that I'm going to use C, right? I just don't see C doing anything further in this proof, so I'm going to bring down the T. Okay, now let's start to dig in, right? So far, I've just broken apart all the pieces, right? It's like getting a bunch of Legos. I've torn apart the box, and all the Legos are spread on the ground. Now, it looks like line 2 is something that we want to look at. And you might say, oh, great, I'm going to do another simp, right? I'm just going to break apart this not F and T. But you cannot. You can't do that because this negation prevents you from doing anything with it. If it just said, I'm covering you can't see my hand on this, but if it just said not F and T, then you could break them apart. But this negation seals it off and makes you have to do something with it. And there's only one thing you can do with it. And by the way, it's called modus ponens, or excuse me, De Morgan's. T. Okay, so this is going to be 2 De Morgan's. Okay, how does this work? These are 2, ooh, and how is this all the wrong size here? Ooh, okay, nay. Hold on. We'll go to one bigger. There we go. Okay. How did I go from this to this? If that doesn't make sense, then I'll explain it. I did a De Morgan's, and in De Morgan's, you take the negation, you plant it on both sides of that conjunct, and then you switch that conjunct to a wedge. And that's what I did, remember? You take a drink, oh my gosh, right? You take a drink, oh my God, it's gross, so I'm going to spit it out. I'm going to put that negation on the F, and this negation on the T, and then my tummy is turning, ooh, so I change that conjunct into a wedge, and bam, there it is. Not F, wedge, not T. Now, I want to get an F, right? And I'm going to get an F, but it's going to take a little bit of work to get there. What I'm going to do to get my F is a DS. I'm going to do a disjunctive syllogism on line 6. But in order to do it, I have to have the negation of not T, right? Disjunctive syllogism looks like this. P or Q, not P, so Q. So I have to negate whatever that one side of the disjunct is. Well, guess what? The part of the disjunct that I want to negate itself has a negation. So I need to turn this not T into a not T if I want to pull off not F and get my F. In order to do that, I have to do double negation on line 5. So what it looks like is not T. And the rule for that is going to be 5 double negation, right? Double negation is a rule of replacement where if I said something true, right? Professor Vid is really totally awesome. Okay, that's true. And then I said Professor Vid is not really totally awesome. That would be false. And then if I said Professor Vid is not really totally awesome, then that would be a double negation and it would be true again. It's like two negatives making a positive. So 5 and 7 are the same thing. They have the same truth value, but double negation lets me put that not in front of it. I'm now going to use that double negation to bring down half of that disjunct on line 6. So let's make that happen. Okay, so we have not F. And that's going to be 6, 7 disjunctive syllogism, right? You can have ice cream or you can have cake. You cannot have cake. Okay, then I'll have ice cream, which is not F. And I'm going to use the same rule again. Come on now. Got to hit that space bar. Doesn't matter. None of them are lined up anyway. Way to go, Professor Vitt. Big help here. Okay, and then we're going to do F. And that's going to be 8 double negation, right? Not F is the same as F, and the rule for that is double negation right here, right? If I have a P, I can go to not P. If I have a not P, I can go to P, right? Okay. So that does it for L. Let's finish up with the last one, and let's finish strong. What do you say? Let's look at problem number S. This is the last of the proofs that you have to be familiar with for the final. So take a second and realize you are almost through this forsaken review of natural deduction proofs. Okay, here we go. We ultimately want to conclude T implies N. I don't see T implies N in a very straightforward way up there, but I do actually see it. So you can just start a proof if you want and work it, and you'll probably get there. But sometimes I like to just take a little peek, right, and check out what's going on. So if I look at the second half of line 1 and I see T implies not S, and I look at my last line, I have not S implies N. So I could get T implies N if I could get rid of this part, and then I did a hypothetical syllogism, right? If that doesn't make sense, don't worry about it. We're just going to work it as the world turns right here. Okay, everybody saw it. That tabbed just right. So when I try to do it next time, it better do it perfectly. And if it doesn't, it's not my fault. Okay, so if you're just looking at this proof, you want to look for low-hanging fruit. It's always our tactic. It's always the best tactic. So I see low-hanging fruit in lines 2 and lines 3, right? And it's hypothetical syllogism HS. It's the high school rule. If Bob is talking to Karen and Karen is talking to Mona, then Bob is talking to Mona. You just take Karen out of there. So that's what I'm going to do for line 5. I'm going to say B, and remember I'm going to use the arrow because it's a little bit easier for me because this ampersand is difficult to get a hold of. Oh, fine. I will cover over it. All right. B implies not M. Excuse me. That would have been disastrous. That's an excellent example of how sometimes you can short circuit yourself on a proof, right? I've been doing this for 20 plus years, and I made a mistake. So when you make a mistake in a proof, you should not feel bad about it. It means you're comfortable and you're working a little too quick and you made an error. It's fine. If you get stuck, make sure you go back through the proofs, the steps that you've already worked, and make sure you didn't make a mistake in one of the steps that you've already worked. Okay. So now I have B implies not M, and that's from line 2, line 3, hypothetical syllogism. And just as a review, the hypothetical syllogism rule is right here. Pete is talking to Quincy. Quincy is talking to Roberto, so Pete is talking to Roberto. Hypothetical syllogism. All right. That's for another video. Okay, here we go. So I have B implies not M. Now where could I use that? Anytime you do a step in a proof, you might want to stop and ask yourself, okay, can I do something with the product of that step that I couldn't do before? Well, in fact, yeah. Look at B implies not M. This conditional in line 5 simply is the first half. It's the antecedent of the conditional in line 1. So you can do a modus ponens and bring this baby down right here. T implies not S. Boom, there it is. Whoop, there it is. So that's going to be 1, 5 modus ponens. So, we're getting there, right? We're not exactly, see? Everybody saw it. It wasn't working. Okay. T implies not S is super helpful to us because we have a not S implies N. So if Tia is talking to Sunny and Sunny is talking to Nora, then Tia is talking to Nora. And I'm going to fix that so it's the horseshoe, not the arrow. Come on. Oops. This big convoluted thing. There we go. Okay, so I get that from, remember our lines that I get it from? It's going to be from line 4 and line 6, hypothetical syllogism. There it is. T implies N, and that's our proof. 3 steps. All right, so if you're comfortable with the proofs that we've worked, you should be in really good shape. So I want to encourage you guys to work these a few times each. That way when you come into class for the final, you'll remember how to work them. Yeah, so I hope that's helpful, you guys. You've caught up to speed on natural deduction, and I'll release a second video that talks about the fallacies. But that one's going to be super short, remember, because there are only like 15 questions on that portion of the final, right? So it's going to be pretty quick. All right, thanks, guys.